make breakfast, pedal a bicycle, read a chemistry book. Energy changes in chemical and physical processes. Our bodies need energy in order to perform various tasks such as get out of bed, make breakfast, pedal a bicycle, read a chemistry book, and so on. The energy needed to carry out these activities comes from the chemical changes that our bodies induce in the food we eat. What is energy and what different forms does it take? Why do some chemical changes release energy while others absorb it? This topic will attempt to answer such questions and then apply our understanding of energy to some of the important environmental issues that people face today. Energy is the ability to do work. This energy is stored in food, fossil fuels such as coal and oil as chemical energy. There are many forms of energy which include chemical, heat, electrical, and mechanical energy. Some substances have energy as a result of their particles moving. Such energy is known as kinetic energy or Ke. Other substances have energy by virtue of their position. For example, coiled spring. This type of energy is known as potential energy or Pe. The two forms of energy are interconvertible. Potential energy can be transformed to kinetic energy. For example, electrical energy can be transformed into light energy and heat energy by passing electricity through a bulb filament. Energy cannot be created or destroyed. Energy changes bring about physical and chemical changes in substances. For example, when other forms of energy are converted to heat energy, there is a change in temperature. The following video clip shows the reaction between sodium hydroxide solution and water. Click to play the video and observe what happens carefully.
The following video clip shows the reaction between sodium hydroxide pellets and water. Procedure. Put about 25 cubic centimeters of water into a beaker. Measure the temperature of the water using a thermometer. Show the temperature of the water in the thermometer. Add 3 spatulafuls of sodium hydroxide to the water. Use the thermometer to stir the mixture.
From the experiment, we observed that on adding sodium hydroxide pellets in water, the solution formed resulted to an increase in temperature. This means that the reaction generated heat, which was lost to the surrounding. Reactions that result to heat loss are said to be exothermic. If you place your palm on the beaker, it feels hot. In an exothermic reaction, heat energy is given out and the temperature of the surroundings rise. The following video clip shows the reaction between water and potassium nitrate. Click to play the video and observe what happens.
The following video clip shows the reaction between water and potassium nitrate. Procedure. Put about 25 cubic centimeters of water in a beaker. Measure the temperature of water using a thermometer. Add 3 spatula full of potassium nitrate to the water. Use a thermometer to stir the mixture.
From the experiment, we observed that on adding potassium nitrate in water, the solution formed resulted to a decrease in temperature. This means that the reaction absorbed heat from the surroundings. Reactions that result to heat gain are said to be endothermic. If you place your palm on the beaker, it feels cold. In an endothermic reaction, heat energy is absorbed and the temperature of the surrounding fall. The water put in the beaker is said to be at room temperature. The temperature changes depending on the type of reaction resulting from the substances added. The animation below shows this concept. Click on the letters A, B, and C to observe what happens. Enthalpy refers to the heat content of a system and is denoted by letter H. Enthalpy is not measured directly, but heat lost or gained by the system is considered. This heat lost or gained by the system is referred to as enthalpy change, denoted by delta H. Delta H values are usually given for systems or processes occurring at constant temperatures. In terms of products and reactants, change in enthalpy equals to enthalpy of products minus enthalpy of reactants. In exothermic reactions, heat of products is less than that of reactants and the value of change in enthalpy is negative. In endothermic reactions, heat of product is greater than that of reactants and the change in enthalpy value is positive. Energy level diagrams for exothermic and endothermic reaction. Energy level diagrams are used to show relative enthalpies of the reactants and products. On the x-axis, it shows the progress of the reaction from reactants to products. The y-axis shows the enthalpy or heat content. For the exothermic reaction, the enthalpy H of the products is less than that of the reactants. The enthalpy change will be a negative value. The enthalpy value is negative and reaction is exothermic. For the endothermic reaction, the enthalpy H of the product is more than that of the reactants. Hence, the enthalpy change will be a positive value. The enthalpy value is positive and reaction is endothermic. In this lesson, we will discuss latent heat.